Welcome to The Explainer. Today, we're going to pull back the curtain on something you use literally every single day, the internet. It feels like pure magic, but what's happening behind the scenes is one of the most incredible engineering achievements in all of human history.
I mean, it seems totally instant, doesn't it? But when you hit enter, you're actually kicking off this wild journey for your request, a trip that can go across the entire globe and back, all in the blink of an eye. All right, so let's break this whole thing down. It all starts with the URL you just typed in. And, it's way more than just an address. It's actually a very precise set of instructions for your browser. See, every single part of that URL has a specific job to do. That HTTPS part, that's the scheme. It's basically telling your browser, hey, make sure this connection is secure and encrypted. Then you've got the domain, which is just a human-friendly name for some powerful computer, a server, that's holding all the website's files. And that last bit, the path, that points to the exact page or file you're looking for. So now the browser knows what you want, but to actually get it, it has to figure out where on this gigantic global network that server is. And to do that, it has to translate that friendly name into something a computer can actually use, a string of numbers. So how does it do that? Well, your browser uses something called the Domain Name System, or DNS. And honestly, the best way to think about it is like the Contacts app on your phone. You don't have everyone's number memorized, right? Of course not. You just search for their name and your phone pulls up the number. DNS does the exact same thing, but for the entire internet. So DNS takes that memorable name you typed in, like google.com, and it finds its unique IP address. This series of numbers is the server's precise location on the network. And with that numerical address in hand, your browser finally knows exactly where to send your request. Okay, address found. Your request is now ready to hit the road and travel across the internet's incredibly complex web of connections. But here's the thing. It doesn't travel in one big piece. The system uses a much smarter method to get it there fast and safe. The internet uses this brilliant system called packet switching. So instead of opening one single dedicated phone line for the whole conversation, which is super inefficient, it's more like sending a book across the country one chapter at a time. Each chapter can take a different route to find the fastest path, and then they all get put back together in the right order at the destination. And that's really the genius of packet switching. Your request and all the data that's going to come back to you gets chopped up into these tiny, manageable pieces called packets. Each one can travel on its own, which lets them dodge digital traffic jams and slowdowns. Then they're all reassembled perfectly at the end. It makes the whole system incredibly resilient and efficient. This whole process is governed by a set of rules called TCP/IP. You can think of it like a 4-layer shipping department. The application layer gets your data all packed up. The transport layer, which uses a protocol called TCP, acts like quality control, making sure all the packets arrive safe and sound. The internet layer, or IP, stamps each packet with the to and from addresses. And finally, the link layer handles the actual physical journey over all those cables and Wi-Fi signals. So after traveling through countless routers and networks, your little packets finally arrive at the destination server. And now, a quick formal conversation starts up between your browser and that server. Your browser sends a formal request using something called HTTP, the Hypertext Transfer Protocol. It's actually very direct. It basically just says, hey, get me the file at the path/hello world, and let's talk using version 1.1 of the HTTP language. And if the server finds what you're looking for, it replies with a status code. 200 OK is the universal sign for success. I got it. I'm sending it your way. It then attaches all the website's data and sends it flying back to you, you guessed it, in packets. Now your browser gets to be a digital construction worker. First, it reads the HTML file, that's like the blueprint for the whole page. Then, it looks at the blueprint and sees it needs other materials, like CSS for the paint and style, JavaScript for all the cool interactive features, and of course, all the images. So it makes separate requests for each of those things. And as they all arrive, it assembles the final, beautiful web page you see on your screen. This whole dance of technology is absolutely amazing, and it all happens in just milliseconds. But the internet's physical bones, all those cables and towers that carry the packets, they still have one huge challenge. And that challenge is simply geography. Laying massive fiber optic cables under the ocean or building cell towers in really remote or sparsely populated areas is incredibly hard, and it's incredibly expensive. This creates these digital divides, leaving huge parts of the world with slow or even no internet connection. But this is where the next frontier comes in: satellite networks. Companies are launching these massive constellations of satellites into low Earth orbit, and the goal is to blanket the entire planet with high-speed internet. And this isn't just about connecting a few remote villages. This is a total game changer for everything, from farming equipment in the middle of nowhere to enabling a whole new generation of remote work from literally anywhere on Earth. This constant, relentless innovation is what has defined the internet from the very beginning. From a simple request to zipping through cables to a global network of satellites, the journey just keeps evolving. And that leaves us with one final thought. As this network becomes truly global, connecting every single person and device on the planet, what incredible new possibilities will that unlock?